Thank you very much for joining my session. My name is Chris Atkinson. I'm a solutions architect, and I'm based, as you can probably tell by my accent, not out of this native land. I don't enjoy your fantastic weather, unfortunately. Although I did speak to somebody yesterday who said that the fantastic weather that he enjoys is around minus 50 degrees centigrade in the winter. I see that California is something of an oddball. I mention kind of the weather is a bit of an oddball because MarkLogic is a bit of an oddball. But an oddball in a good way. David Gorbett mentioned this morning in great detail how we managed to do two things that are really, really difficult to do at a database level or data level. We managed to provide something that allows you all of the benefits of a data lake, but somehow, at the same time, through sheer magic, it also provides you something that allows you to operationalize data as well. And that is going to be a theme that I'm going to be running through this particular presentation. So as much as this presentation is about how to govern data and ultimately prove it, I'm going to demonstrate to you a more practical approach, a little bit more deeper technical detail than David's presentation this morning, and I will be covering GDPR, okay? On the GDPR front, I'm actually really impressed. I honestly thought I was going to get here this week and I was going to have to explain in great detail GDPR, but it seems that everybody knows what GDPR is. And I'm only assuming that because Facebook are doing their level best to make sure that it doesn't apply to them. And have done a good job too, it has to be said. So thank you very much for coming. I'm going to crack on. And my first kind of statement or kind of thing I'd like to lead into is we often talk about data governance, we talk about relational databases, but the big challenge that a lot of us see is actually how do we add data governance to a data lake? Or more specifically, how can I get data lake type capabilities that have data governance? Now the big attractive part of any data lake is that it has this particular piece here, which is the schema on read. Now, can anybody tell me what schema on read actually means? Anybody willing to take a stab at it? Nobody. Okay. Oh, go on. The schema is not defined in, did you say internal database? That's a pretty good shot on it. I would take that a little bit further, because I think you're absolutely right. And I'd say, if you look at it, it's easier to explain by what schema on write is, because you're all familiar with schema on write. Schema on write is you create the structure of your data, and then you pour the data into it, right? Rows, columns, tables. You build the structure, you define the types of data that are going into that structure, the shape of the data, and then you basically put the data into it. And if the data doesn't fit, what happens? You get a hammer and you hammer the crap out of it until it does fit, right? And you get DBAs to do that. So you're absolutely right. Now, schema on read, by default, means that you don't define that structure up front. You actually define that structure at the point of, somebody said ingestion, okay? That's wrong, I'm sorry. Somebody said read, which I think was you, so that's cool. So this is the whole point. Now, that gives you an advantage because you're not creating structure in advance of the data arriving. That means you can effectively ingest the data in its native form, okay? That has some significant advantages. That means you can support any shape of data, and you join that data at the point that you read it. Ultimately, much more efficient, less upfront muddling. You don't have to strip it into rows, columns, and different types, so you don't lose any data in the process. And very, very importantly, this is where we see great functionality for analysis, OLAP type workloads. Works brilliantly. Now, there are challenges with this, because otherwise we wouldn't be here today having this conversation around data governance. And the data governance challenges come from this particular challenge, which is when we look at a data lake technology, conversely of how the learning that we've had with data management over the last kind of 30 years is most data lakes don't have a lot of governance technologies. We don't enjoy things like transactional consistency. We don't enjoy audit capabilities at a deep level, security at a deep level. These are typically things that you bolt on after the fact, okay? And that's part and parcel of this whole kind of unstructured way of dealing with your data. The result is that you have to put a lot of components, scripts, plugins into that data lake or surrounding that data lake, or you have to build it yourself. And as a result, you also see much less performance. And as a result of that, you actually don't get to see very many data lakes supporting OLTP workloads. In fact, has anybody here got an OLTP workload on a data lake? Okay, I'm glad nobody put their hand up then, because that would have been embarrassing. So that's kind of the operational data challenges around that. And this manifests itself in two ways. Again, I think David actually stole most of my content this morning. I'd like to think I was the inspiration for it. You end up with like a two-state solution, effectively. The first state is that you have your operational application databases sat using relational technologies because the data governance tends to be better there. They're transactional. They're great for OLTP. And on the other side of it, you have your data lake, which is kind of the reporting side. David referred to it this morning as kind of run the business. What was it? Run the business and observe the business. That's right. I'm glad you're all paying attention. There is a better way. Okay. So this session is about a practical approach, and I'm going to take you through a real example, okay? But I have changed the names to protect the innocent. This is a real institution that had this problem, and they threw millions and millions of dollars, so that narrowed it down to a few banking institutions. I don't think I'm giving too much away, every year on solving this particular problem. And they didn't solve it. They just acknowledged it as a problem and just paid the bill, okay? Does that sound familiar to some people? Yeah. So the first thing is Operational Data Hub. What do we actually mean by this? Well, it's still schema on read, but we often refer to it as a multi-model database. That often makes sense to a lot of people. People coming from the DBA background in a relational system, they know what a data model is. And if you say to a relational guy, schema on read, they often think, no, I'm not entirely sure what that means. But if you tell them that you've got a multi-model database, a database that can house multiple data models within the same database and allow you to join them at query time, they get it, right? So if you're going to have this conversation internally and the guy turns around and says, oh, looks a bit glassy-eyed and says, don't know really what it is, explain what a multi-model database is. It is transactional. It has search capabilities that mean you can discover new facts and information from the information that you hold in the database. And importantly, really importantly, it's indexed. Okay, which means it's fast. Okay, it means you know what's in the database, and for that reason, you can support OLTP and OLAP workloads at the same time. Now, David mentioned a few things around EU GDPR, and I'm going to take an example today of walking you through this particular nasty problem. Now, EU GDPR breaks down to 5 particular tenets, and all of these tenets are about data governance, right? So every other EU regulation that has come along has been extensively rewritten within a couple of years. That's the first comment. And they have never, ever prescriptively described how you must do your data governance. This is one of 2 ever EU regulations that has attempted that, and it specifies how you must govern your data. We have never had that before. So previously, regulation was you need to do this for your clients, but how you do it's up to you. Now they're actually being prescriptive on what that's going to look like for you. It breaks down into these 5 tenets. The first one is consent. And I'm going to simplify it into you must give consent explicitly as an individual for your personal information, which is anything that can define you as an individual, for purposes other than what are called legitimate grounds. Legitimate grounds are things which you must give permission for the resolution of the service. So for example, if you're signing a contract for a house, then you don't need to give consent for writing your email and your phone number down or your address, right? Because it's implicit. But for them to contact you at a later point regarding marketing, they need to get your consent to do so. And it's got to be explicit. They also have, we're starting to get into the infrastructure layer, the actual governance of how you're going to do it on your operational side, but you need to report breaches, not only to the regulator, but also to your customers. And you need to explain what the breach entails to them. You need to be able to guarantee that security is built into your service at a very, very deep level. So winging it and saying, I think we're going to do this at the application layer and this is how we're going to do it, generally is not going to cut the mustard anymore. You have to do this very, very clearly, explicitly, and security must be ingrained to every component that you design. You must be able to respond to what's called a subject access request within 30 days. Does anybody know what a subject access request is? Do you use that terminology over here? Okay, basically, tell me what information you hold about me in your entire organization and how you're using it. Can anybody answer that question about their customers right now? Okay, could anybody answer that question in 30 days about an individual customer? Okay, there's no hands going up, which means, and that's probably either because you're embarrassed or you're very shy. Very few companies can, right? Very few. The final piece is around the right to be forgotten. That means, by the way, the right to be forgotten is that any personal information. Do you think a photograph of me holding a fish on Facebook is personal information? Right. It's got my face on it. It's personal information. And it has to be done easily, either by the client or by you. Okay? This is a tall order. So we're going to take an example, right, of a guy called Harry. And Harry is a customer of ABC Bank. Okay? And Harry has had a lot of spam email about various different services from the bank, and he uses various services at the bank across retail, across their financial services, across mortgages, and he's kind of had enough, right? Like a lot of us, he really just wants to unsubscribe. So in the GDPR, he actually contacts ABC and he says, hey, I want you to take me off. I'm not giving you consent anymore. Take me off the lists across marketing. So he contacts them. Remove me. And he contacts the finance department, who he normally deals with. The very next day, he gets an email from a different part of the bank, the retail arm of the bank, who are trying to sell him services, and that confuses him quite badly. He's like, I only requested this yesterday, the bank are ignoring me. So he basically goes from kind of reasonably smiley face to a little bit quizzical face. By the way, I created these smileys myself, I'm quite proud of them. Especially my angry face, which is coming up. The very next day, something else happens, right? Which he now gets an email from said bank saying, we're really sorry, but your data's been stolen. Your personal information, your social security numbers have been stolen, your passport information has been stolen, and for the next 30 years, you just need to pay special attention to whether you're being cloned or not out of somewhere in northern Russia. At this point, he's kind of like expletive, what the hell face. So what does he do? He does what a lot of us do at this point. I don't feel like I don't trust these guys. They're not listening to me. So screw you, forget me, right? Get me out of town. So he tells the finance department again, forget about me. And what happens the next day? Can anybody have a guess? He gets an email from the insurance department then trying to sell him some car insurance, right? At this point, he's angry face. And he gets in touch with his lawyer. And his lawyer files a subject access request. The subject access request goes to the compliance department, and the compliance department, well, you can imagine that they're not dealing with one of these complaints at a time, right? They're dealing with hundreds, thousands of them. The compliance department have worked out that it takes on average 2 man-days to find the data that he's requesting, and with GDPR also the proof of how the data was used in terms of what it was used for. The bank has no option. They know that they can't do this, so they just turn around and say, we'll pay you off. Now, the bank in New York that dealt with this, by the way, it wasn't under EU GDPR, it was actually less detailed than this, just set aside several $1 million every year to pay fines. They did not have a discovery and compliance team to deal with it, because they knew they couldn't solve the problem. So how do we fix this? Well, first of all, we need to understand how the problem occurred in the first place. So the first thing is the data was integrated very poorly. Nobody had a view across the entire business of what Harry's consent was, what he had given or not given permission for. The data was also not operational. There might have been a lot of information in there, but there was no way of updating that information directly either by Harry or the person that he contacted. And the breach demonstrated that there was insufficient security within the systems to safeguard his data. Ultimately, the final piece in the kind of chain of failure was that there was no way that they could identify how his data moved through the system and where his data was within the system and who had acted upon it, the chain of custody of his information. So those are the things we need to fix. So being a solution architect, I spend a lot of time doing practical stuff, right? Helping developers design solutions that fit the customer's needs. So the first thing is that a lot of people are turning around right now and saying, I want to fix this, or I want to fix something like this. I want to do digital transformation. I want to create 360 views of my customer. I want to move my company over to a digital platform of information. There are lots and lots of initiatives. GDPR is one of them. Consider it to be an advantage. This is a point in time, just like many others, and there will be more next year and the year after. The one thing you can guarantee is that there are going to be more of these. It is an opportunity to leverage a budget to deliver something tactical which you can scale at over a longer term to do full digital transformation across how you manage and govern your data. And this is the starting building block of it. Use that first tactical win as your requirements builder for the rest of your solution. Now, Normally I go through this, but I'm going to ask a question, which is, and if everybody doesn't put their hands up, I'm going to go through this, which is, does everybody in this room understand what a document database and what MarkLogic's document database does? I'm going to put my hand up. Who else can put their hands up? If everybody doesn't, I'm going to go through this slide. Okay, everybody didn't, so I'm going to go through it quick. We store objects, we store documents. That's not Excel, although we can store Excel or Word. Okay, we store entities, discrete and distinct objects of information as they exist in the natural world. If you fill in a form and you digitize that, that's a document. That's how we store it in the database. We retain the original structure of the data, we ingest it as is, and we can support lots and lots of different types of data. So for example, we can, from my world where I deal with financial institutions, or XML is super common, right? So XML transactions. JSON objects, right? The developer's favorite kind of object to work with. Financial reports, a PDF document, we can ingest that, we can derive new metadata from it, we can query it and index it as it exists within a database, or we can store it as, other databases would, as a blob, and we could attach metadata to it. And we can also do unstructured data, such as a phone transcript, okay? That's how we work. That's all you need to know for the next piece. So let's start breaking Harry's problem down, which is a governance problem. The first thing is, we ingest the information in its native form from a number of sources. Remember, the challenge with Harry was that nobody had a clear view of his information in a single place, in a congruent view at a point in time. So what we do is we take Harry's consent information from all of these upstream sources, and when we ingest it, we index it, we secure it, and we audit it all at the same time, all using MarkLogic inbuilt technologies. This is easy. This is bread and butter. You don't even have to turn stuff on to do this. And the result is just taking two of these examples, we have this, one piece of data here and one piece of data here. They contain exactly the same pieces of information for Harry, but from two different sources. Okay, so it's profile, when his consent was updated, what his consent actually was, and what his ID is within the environment. Okay. So the next piece is, in order to expose that into one view, I want to know what the last update was to his consent across all of my sources, right? That'll give me the view of, do I have his consent to mark it to him? Okay. In order to do that, what we use is a semantic mapping technology within MarkLogic, and we use that to literally map source to output. And we do it at query time. We're not synthesizing anything here. We are literally at query time saying sysID is the same as customer ID, and I'm going to expose customer ID. And then what I do is I run a function across these two documents, and I say, just get me the latest version. Okay? So what I have now at query time is an accurate view across multiple sources of Harry's consent. Okay? Does everybody get that? Is this simple? It is, right? This is not difficult to do, at least not in our database. So we've solved the first problem, or actually we've solved the problem halfway down the stack, which is when Harry said, I've taken my consent away, people still communicated with him. In order to solve this in the environment, all we need to do is when marketing or any other department wish to use Harry's data for a consent-related purpose, they need to contact this API to see whether they can do so or not. They do not refer to their own copy of consent, right? Because it could be out of date. And we're not going to update their consent. We don't need to. We've just created an endpoint which is surfacing consent information. Super cool. But we can do better than this, right? Because to be honest, I can go out there and I can probably find a few solutions on the market, another application, right, to do GDPR. And one for MIFID, and one for EMEA, and one for MIFI, and I can keep going on and on and on. And I think most of us have seen a lot of applications on different databases with different ETL. What we want to do is we want to start doing bigger and better things and repurposing or extending the purpose of the information we're gathering so that we can satisfy more use cases with a single database upon which all of our applications can sit. So let's we already understand from our knowledge of document databases here that it was very, very easy for us to pull a little subset of that information into one place, right? Now, because we're not defining columns and tables at the point that we're ingesting information, how difficult do you think it is to actually pull more information from those sources rather than just the consent ID, the date, and what the status was? It is as literally as easy as saying, well, actually, why don't we pull all of his data in, all of his profile data in, right? And let's do that from his retail banking from the retail banking app or business and actually do it from the insurance business as well. And what I can see now is I can see something really cool, right? Which is joining this information together, I can see that his current bank balance is minus £200. This is something that I'm familiar with because of my wife's love of shoes. And we can also see that Harry's car insurance is due pretty soon. It's expiring pretty soon, right? So it doesn't take a huge complex algorithm to work out that Harry is not going to have a lot of money on the 31st of the 6th this year. So what we do is we contact him, right? And we say, actually, with this view, this 360 view of your data, we can add some value to you, Harry. Would you like us to extend your overdraft for a month? So Harry gets this email, and look, unlike all the other emails he gets from all the other organizations he's getting, he gets an email that says, Harry, we know you've just bought a car. Would you like us to extend your overdraft for you, free of charge? And Harry is like, wow, this is pretty cool. My bank know me. They're trying to help me. They are providing services to me. This is not a fictitious conversation. I had a conversation with a Dutch bank really recently, who we're implementing right now, and their exact words were not what they wanted to achieve technically with our solution for GDPR. It was the value they could provide to increase their loyalty of their customers. That was their statement. And this is how you do it. So now what I've got is I'm providing a 360 view to my business in exactly the same way that we did consent, and I'm doing it at query time, and I'm doing it instantaneously. And this means that for the first time, a lot of companies, just by extending the original use case, which was GDPR, have done something that's typically really difficult to do, and they haven't done a whole lot more to achieve it. Okay? Now, what we've done here, we've solved quite a lot of the top-end problem, at least as far as Harry's concerned. He now gets a trusted advisor, he's not getting spammed, and if he doesn't like the email and he turns it off, he doesn't get any email anymore, right? Pretty cool. Operationally though, we, the people who manage this stuff, we're still looking for that bit of a further extension, right? We want to operationalize this data fully. We don't want two separate solutions to read, report, run the business versus operate and view the business. So what we do now is we take this one step further. Instead of generating this customer 360-degree view at read time, we actually materialize it. We create it in the database. So instead of it just being a memory artifact, what we do is we actually build it. It becomes a document in the database. It becomes real. And that means we can start to do some very, very powerful things. Because it's real, we can update it directly. Yeah? We can interact directly with this object, this customer 360. We can append new information that doesn't exist here directly to that information. And that means we've now just operationalized it completely. And that means we can now start to expose this through different views to different APIs for different services and requirements. And we can do so in such a way that it performs at breakneck speed. And that means we've just satisfied something that's really difficult to do. We can now do OLTP workloads on aggregated data. That's cool, right? Tell me that's not cool. That's amazing. So it performs, and it's transactionally safe because it's a MarkLogic database. You know, I've operationalized my data, and I'm reading it from the same place and aggregating it. It's great, okay? And I've got real business value here. I can, for the first time, do something that I know 100% is accurate, that everybody's working from the same view. If I have a calculation that is done in the risk department, I can attach that risk calculation to this customer so that other consumers within my business can see that risk calculation and can make decisions based upon it. That's just an example. So we've operationalized Harry. We can provide him even more value, and we have more insight. Now, a big question that I often put up against at this point is, that's really interesting, Chris, and that's awesome, but when do I create new entities? So what we've done here is we created this, this customer profile entity, but what about an insurance purchase, for example, or a trade? Do I put those into his customer profile? Because I've heard about denormalization and you should stick everything into the one entity, right? No, that's not the answer. So I created a flow chart that helps me decide what I do with new information that arrives in the database. And the first thing I do is I decide, is the new information that's arriving, is it related, tightly related, i.e. part of the same entity as the entities I already have. So let's say it's an insurance purchase. So we have Harry's profile, his customer 360. Do you think, just a kind of straw poll here of hands, who thinks that his insurance purchase should go inside his entity? Okay, just making sure. Who thinks it shouldn't go inside his entity? Okay, good, just making sure that, because if no hands went up then. And you're right, okay, so all the hands that went up, second, you're all positively correct. It's not absolute, it is related, but it's not part of the same entity. So what we do is we create a new entity in the database. But over time, dealing with 50, 60, 70 different applications, we can create different entities for all of these. So over time, what can happen is if we start to query across all of these entities, we're doing joins across them, we can start to see our performance degrade. Query time. So what we ask at this point is, do we think that the query performance of doing this as a separate entity is going to degrade our performance? And in this case, we're going to turn around and go, yeah, actually, we've just got to a point where we're doing so many joins across so many entities, it's actually starting to suck a little bit in performance. Not bad, but we can start to see this starting to slow down. At that point, we actually do something clever again, which is we create a query entity. And the query entity has pre-processed those joins for us, and it's materialized the answer for us at the point of query already. Okay? So it's done much of the hard work for us before we actually query it. Okay? So we've just optimized the query. The golden rule here, generally speaking, is you don't need to start doing this until you start to see performance decreases. So as you build it up, as you get a view of your data, as it starts to slow down your database, then you optimize it. So it's an agile and iterative process of optimization. You effectively move some of the read load to the front where you pre-process and materialize these entities to improve your query performance. Now, we've still not solved the problem of Harry's security. Right? We've solved a big operational problem, we've solved a value problem and a consent problem, but what we haven't solved is when some nasty person from a foreign land hacks our database and steals the data, we lose credibility with our customer. MarkLogic has some pretty awesome security features in MarkLogic 9. The first of those, and one I would highly recommend you to use, is the element level security. Element level security allows us to define particular attributes of the documents within our database and secure them independently of the rest of the database. You cannot access that data unless you have the role associated with reading those attributes. And the best way of doing it is to create a red list, a white list, a black list, and a gray list. Okay? The white list is stuff that I know is safe. Attributes that will never contain personal data, okay? So his ID, his account type, and his consent status will never contain, ever, personal information. We know that. His email address, we absolutely know will contain personal information. And then we have the transcript, the notes from the call center. Now, we don't know whether that contains personal information, but it's likely. So what we can do here is we can always pass that through a further enrichment engine external to MarkLogic to say, can you scan this and identify if it's got social security ID patterns, all that kind of stuff. And we can actually gain more information about that. But initially, until we've actually done that, what we do is we add the email and the notes to the database protected paths list. And that means that unless you have the roles associated with reading those particular paths, you cannot access that data. And the cool thing about this is it does a couple of smart things. The first one is it obviously safeguards direct access to this document. As a hacker, I could compromise a number of accounts that have access to this document, but I'd still have to hack the additional account that gives access to role to read those attributes. So it's more secure. But also, from a management point of view, what I actually have done is I've secured by default the personal information inside the system. That takes away a lot of headaches. I've done it down here, which means I don't have to keep doing it at the layers above, so for example, the application layer. So that kind of secures it at that level, but we've still got to stop the data from being stolen, period. And the first defense against stealing the data is at the infrastructure layer. You do need to stop people wandering off with the disks or the data files, okay? So the simple way of doing that is you encrypt the data. Now GDPR, if you've got an encrypted database and somebody walks out with it, you don't actually have to report a breach if you've encrypted the data. Okay? If you've encrypted the data within the database and somebody hacks it, you don't need to report a breach. Okay? It's pretty cool stuff. So obviously without any qualms, what you need to do is use MarkLogic's database level encryption. But most people do not walk away with disks, although they do walk away with data files on a frequent basis. A very, very common hack is actually via APIs. And the reason why APIs get hacked, can anyone tell me why APIs get hacked so commonly? Decrypted. That's definitely true. But also they're exposed, right? Of all of the bits that touch the outside world, it's the APIs that they're going to go for, right? So, and yeah, not encrypted, right? And the really scary bit is what often happens is, and I used to work for a security company where we demonstrated this time and time again, is you need one person to, I think they call it tailgating through a barrier with a hacked API, sets up a console, and he's just got access to your database console with a hacked account. Ooh, does that happen? Of course it does. So let's take an example. We have the API that deals with consent. This API, all it's supposed to do is you give it an ID and you can update or retrieve the consent from that ID. That's all it takes. Now that API reads and updates consent. It gets assigned a normal permission, okay, or a permission with a database. And this is MarkLogic, by the way. This is how it works. And then we read and update that document. So when that hacker gets access to that API and sits on that console, what do you think he's got access to now? Can anyone tell me? Do you think he's got access to the user's profile? All of it? No? Why not? But that API had access to the document. It's got to read the entire document and write the entire document, right? So that API, in one way, shape, or form, if he's broken into that API and he's got access, he's bypassed the API, he's got the access account, right? And he's on the console for that, using that access account. He's no longer restricted to the declarative attributes. He's got whatever that API's got access to, and he's got access to read the document and write it, and he's got a USB stick, and he can dump the whole goddamn lot out.
But it's limited by the user profile of the ID he's hacked in.
It is, but in order to update the profile, which didn't just contain consent and ID, it had his address and all the other details in his profile. He now, unless you separated those out, right, you've actually got a situation where he can read all of that user's profile's data. Or you can actually start to get crazy and start separating out at an entity level all of your private data from your read data. The easier way to do this, and a more secure way, is to use a very, very cool feature in MarkLogic called the AMP function. Anybody used this, by the way? Anybody here used AMP? Okay, cool. So AMP is great because what AMP does is it gives you permission to read a function, and that's it. And then what we do is we amplify the permissions of this function. So even this user, even if I stuck him on the user console, the only thing he can read, this hacked user, is the getUpdateUser function. And he can pass it those two parameters, and he can update, and he can read the consent, but he has absolutely no fundamental way that he can actually read the rest of those permissions. Sorry, the rest of the document. So he can't dump it. All he can dump is consent and ID. That's all he can read across the entire database through that function, which means we don't have to report a breach to Harry because his personal information was never compromised. We've actually protected it at both an application layer, at a user level, and also at an infrastructure level. Okay? There are no weak links in that chain. So we've solved a lot of his problems, but we also need to be able to prove it. Remember, the title of this presentation was not just to do it, but you need to prove it as well. And proving it comes down to a couple of things, right? Proving it to the customer, but also proving it to yourself. Now, fortunately, the W3C have actually done the hard work for you. They've created an ontology, a working practice, if you like, of describing the interactions and how information is read and how it is updated. And this means we can actually, using MarkLogic's RDF technology, map how data flows and how it's integrated in or how it is altered and accessed through your system. So let's take an example. We have profile123.xml, which happens to be Harry's profile. Okay? It is generated by the ingest module in MarkLogic, and it was attributed to branch user 34156, which was the user at the branch who created Harry's profile when he first created his account. Okay? It was derived from message 3527F751S from a message bus. Okay? And the process started at 10:14 and finished at 10:15. We have just captured a lot of the essential components of what it takes to describe how a transaction was performed within the database. And what happens is every time somebody reads that, and every time somebody updates that entity, we store the same information. Okay? Now you could do this with metadata, right? You could stick an extra couple of fields onto the end of a, well, okay, you couldn't really do it on a relational database because the entity crosses numerous columns, right? You would have to store it somehow different. It's an interesting challenge. But what this actually does, which is more interesting, is that you can start to link these together and you can query these attributes from different directions. And this gives you some very, very powerful capabilities. Namely, when I'm trying to identify whose data was exposed, what data I hold about people, and whose access to that data for what purpose, I can query this ontology or this structure with simple ease. So let's take an example. So what I've actually done here is I've taken Harry's profile again, and what I've done is we've actually had Harry update his own consent. So he accessed the consent portal via the website, and he actually updated profile 123 from the consent portal. The purpose was to decline consent, and it was attributed to HCU1235, which was the API username that was actually initiating this. We've actually also created a new attribute, which is has profile. So Harry has a profile, profile123.xml. That means for the first time, we have taken something which combines Harry as an entity to the information that we hold. So I can do this across all of the data in the database. I can look at Harry and I can see all of the information across my database that relates to Harry. Now, if we look at the breach that occurred, the interesting thing here is the marketing API was compromised. Okay, all this is, don't even need to care about it. But his profile was used by the marketing system, which we know was compromised, and that profile is related to Harry. Now, if his data had not been protected with element level security, we would have had to report that breach to him. But because we knew that the marketing system through that API, did not have access to his personal information, we know that although there was a breach there, it didn't actually compromise him. But it was in the news, right? Because the news love this sort of stuff, right? You know, the news aren't going to turn around and go, oh, there was a breach, but nobody was really affected. They'll turn up and go, hey, there was a breach and everybody was affected. So we actually emailed Harry the next day and we said, Harry, just letting you know, your data was not compromised. You do not need to look at Experian for the next 30 years of your life to see whether you bought a car without buying a car. Okay? So this also means that we can prove at any point in time what happened in a breach, and very importantly, what information we hold about a person and how we use their data for what purpose. Very, very powerful stuff. Now, one of the things that you won't get from the provenance ontology is you will not be able to say how information changed over time. The provenance ontology is what information and how people enacted upon it, but it won't say what changed. If you want to do that, then you need to develop an append-only database to keep the history of your data, right? And a lot of the time in a data lake, that's done at an application layer. You start to generate new keys and new versions of the data over time, and then you do complex queries. Great thing is, MarkLogic allows you to do this really simply using our technology, which is called Unitemporal. Okay? Unitemporal effectively keeps the last version of your information in a collection called latest, and as you update it over time, it increments the versions in the back. That means that if I want to see any of Harry's information over the intervening period, I just query back at these points in time. It actually operationally handles everything for you. You do not need to manage your own append-only databases anymore. We handle that for you, that versioning process. Okay? I'm not going to go into bitemporal today, but this is the same API. So if you do have a bitemporal requirement in the future, it is literally as easy as throwing a switch to change this into a bitemporal functioning system. Okay, I'm going to skip this slide in the interest of time. So the bottom line is looking back at Harry, right? The first thing is that this whole problem from Harry stemmed on data governance and the fact that we were not providing him value, right? We're now providing him value. We actually offered him a bigger overdraft on a temporary purpose, which he's delighted at, okay? We didn't spam him, okay? He's not going to get spammed anyway because he's delighted with his service. He actually enjoys reading his emails, perish the thought, because he only gets them once every 3 months, but when they come through, they're related to him because of the 360 view we've got of him. And when that breach happened, he felt safe because he was notified the next day that his data was not compromised. It was actually safe. He now trusts this organization, and he becomes a sneezer. He helps us go viral, right? He tells all his friends. He puts us on Facebook. He goes out there and says, this weekend I was able to actually go out on the drink, save some money or go out on the drink because my bank overdraft is much higher and I don't have to cut back anymore, right? And his friends had a great time because he was out and everybody was happy. But Harry's delighted. We turned Harry from a hater into a delighted customer. We never got down that point, right? And that is what an operational database can do for you, okay? That is why there is value or gold in those hills. You know, operational databases or operational data hubs like MarkLogic, they combine the best of both worlds. They provide you with real business agility that you cannot achieve any other way. Fundamentally, when you're chatting to a CTO or you're chatting to your chief of finance about where the money comes from this, the fundamentals are really simple. You've got to do this anyway, right? Because your competitors are going to be doing it soon. You're going to reduce the risk around your data and the regulatory risk, and really importantly, over time, your maintenance costs and the cost of developing and spinning up all of these different use cases decreases rapidly. Okay, you're just extending your use case each and every time you do this. You don't need to build a new database platform and a new application on top. You just build the application. So before I wrap up, I've got about 5 minutes left, I think, maybe 2 minutes. I don't know what I'm getting flagged at the back. I got 5 minutes. Thank you. What questions do you have, please?
One question.
Yeah.
How do you monitor unsuccessful breach attempts?
Yeah.
I want to hear from you. How do we monitor unsuccessful breach attempts so that we could have a visibility to at all levels, at the infrastructure network level and also at the MarkLogic data layer?
So some of that I'm going to place into my not my problem bucket with the greatest respect, because that touches on many, many different layers. What we do within the database is we monitor those accesses. So other than the ontology, we actually have an audit log that sits outside of the database physically, and every single action of that type, so for example, somebody who is trying to force break a user password, that's logged. So the database level, we will report that. The ontology itself is unlikely to report that because it won't report a failed attempt. But the audit log will actually report that failed attempt. At the application layer, unfortunately, we can't help you with what goes on there. We can certainly act as a repository for storing how breaches were stored. It just becomes a piece of new metadata. So we can help you map that, absolutely. But you do need to add additional logging technologies to the other layers of your environment. But we do have customers where that information is sent to MarkLogic as well, because that helps you tie it together. Somebody who hacked a frame in a VMware environment, got into 2 different VMs, and hacked it, you can actually tie that. We have a customer, by the way, in New York, who maps their entire infrastructure with the RDF technology back to the data as well. So we can help you map it, but you still need to do point tools in order to capture the breach themselves. Yeah, we treat it as another application data set in many respects. Yeah. Thank you. There was a question over here. No? Okay. Any further questions? No? Okay. Well, in which case, just wrapping up. So I come from financial services background, so hence this slide. But this is just an indicator of a wealth of information that you can find on the MarkLogic website. So if you go to solutions/enterprise, there are a whole bunch of solution sheets there that describe just these types of implementations. Make sure you go there, check them out. It's been a pleasure talking to you. Thank you very much.